Alright, chain rule with polynomials. So let's suppose we have a function that's a composite function. So a composite function means f of g of x. I'm inserting a function into a function. And f of x is a polynomial. Then these are the rules. Then we're going to the derivative of the outside. My f of x is where I have a function raised to a power. And then it's going to follow the outside function. It's going to follow the power rule. So I'm going to multiply my n by my coefficient. And so my n comes in the front. I decrease my n by 1. Notice that my g of x stays the same on the inside. So that's the derivative. I call it the derivative of the outside. And then times the derivative of the inside. So let's go through several examples. Alright, so if y is equal to the function 3x squared minus 5x plus 1, the whole quantity is raised to the fourth. This is my polynomial outside function, and this is my inside function. Alright, and so what I'm going to do is I'm going to take the derivative of the red and then the derivative of this, like that skin color, that tan color. So we have y prime is equal to the derivative of the red part, so that would be, it's kind of acting like x to the n, or in this case x to the fourth. Derivative of x to the fourth is 4x to the third, but instead of x, I'm going to be inserting this equation into that spot. So this is going to be 4 times insert my 3x squared minus 5x plus 1, and this is going to be raised to the third. And on the inside, I'm going to have 3x squared minus 5x plus 1. And then I'm going to multiply by my inside function, which is going to the derivative of the inside. So the derivative of the inside is 6x minus 5. And we are finished. Number 2, find the derivative if y is equal to 5 divided by 3x squared minus, or 3x squared, negative 3x squared plus x, and that whole quantity is raised to the seventh. Some of you guys are thinking, isn't this quotient rule because I see a division line? Yes and no. Notice in my top, my coefficient for the entire function is 5. And so I could just rewrite this as 5 times negative 3x squared plus x raised to the negative 7th. And again, it's negative because the 7 is from the denominator. And so now I am ready to take my derivative. My outside function is this negative 7 in the fifth. So if I was going to rewrite this guy, it would be like saying, like, the outside function looks something like this, like 5x to the negative 7. Well, that would be negative 35x to the negative 8. Except for this is going in for where my x is. So let's go ahead and take our derivative. Y prime is equal to, so the derivative of my outside is going to be that negative 35 something raised to the negative 8th, and we're just going to insert my inside function, which is that negative 3x squared plus x, and then I'm going to multiply by the derivative of my inside function, which is going to give me negative 6x plus 1. Number 3, we're going to find the derivative of negative 8 times the cube root of 5x minus 1. So again, if I was going to look at this, my negative 8, this is kind of like in the form of the cube root of x, except for I'm inserting 5x plus minus 1 into that x value. And so if I was going to, I need to first fix this, and so this is going to be equal to d dx of negative 8 parentheses, insert inside function. And since it's a cube root, we're talking about to the 1/3. And so my inside function is that 5x minus 1. So I'm going to take the derivative of my outside function, which is these guys. So it's kind of like negative 8 something to the third. and then multiply that by the derivative of the inside. So the derivative of the outside is going to be negative 8 divided by 3. And then I'm going to decrease my 1/3 by 1, so I'll get negative 2/3. And then I'm just going to rewrite my inside function, 5x minus 1. And finally, I'm going to take the derivative of my inside function, which is going to be 5. Alright, number 4, find the velocity if the position is x of t is equal to negative 4 over 3, the square root of cosine t. And so the derivative of, again, the derivative of any position is going to be velocity, because velocity is your rate of change for the position function, as you learned in Algebra 1. And so again, I need to rewrite this. Negative 4 over 3 is my coefficient. And so if I rewrite this guy, it's going to be negative 4 over 3, and my outside function is this square root right here. So I'm going to have a couple different colors here. So my outside function is that square root. So he is a half, and he is negative because he's from the denominator. My inside function is that cosine of t. And so now I'm ready to take the derivative. So my x prime of t is equal to negative 1/2 times negative 4/3 is going to be positive 4/6, which is 2/3. Let me use the right color here. So positive 2/3. Negative 1 minus 1 is negative 1/2 minus 1 is negative 3/2. And then I'm going to keep my cosine of t. And then I'm going to multiply by the derivative of the inside. The derivative inside is going to be negative sine of t. Alright, find the derivative for f of x is equal to negative 8x times sine to the third x. And so I have a lot of things going on here. First, I want you to be able to see the product rule. Here's the first. Here's the second. And so let me rewrite my second, because you guys don't really understand what this 3 really means. And so let me rewrite it. If it's sine to the third, that means it's sine times sine, sine times sine times sine 3 times. So I could write this as is equal to negative 8x times, here's sine x raised to the third. So let me make this red so you can see the outside function, inside function. Alright, so if I'm doing the product rule, I need to do the derivative of the first. So here we go. So derivative of the first, so f prime of x. Derivative of the first is this blue right here. So derivative of that guy is negative 8 times the second. So I can just kind of keep my sine, my cubed of my sine function, plus my first, negative 8x, times the derivative of the second. Well, the derivative of the second is going to be the outside is this red. Again, it's this red here with the third. So it'll be 3 something squared. And then times the inside, which is that's whoops, wrong color. That's sine x. And then I need to multiply by the derivative of sine. Well, the derivative of sine is cosine. And we're just going to stop it right here. Number 6, find the derivative if h is equal to the negative tan x divided by x. All that whole thing is raised to the negative fourth. And so here I have a outside function, which is this thing here in red. Okay, that's my outside function. My inside function, there's my outside function, My inside function is this quotient rule. And so my quotient rule has my low and my high. And so as you notice, my quotient rule is inside my chain rule, and so I need to do the chain rule first because I work outside in. So if I take the derivative, so h prime of x is equal to, well, the derivative of the outside is going to give me -4, insert inside equation, and then I'm going to decrease by 1, so that gives me -5, and then I'm going to write this the inside part, which is tan x divided by x, and then I'm going to multiply it by my quotient rule. And so remember, my quotient rule is low d high, so derivative of tangent is secant squared, I need to give myself a little more room over here, so put the little parenthesis over there, minus derivative of my, times my high, tan x, times the derivative of my low, well, in this case it's just going to be 1, divided by low, which x times x is x squared. And at this point, I know it's an incredible mess, but let's just go ahead and just leave it. We'll talk about simplifying later. I'm just looking to see, can you do the chain rule and the quotient rule? Alright, find the equation of the line tangent to the graph of f of x is equal to x times the quantity 1 minus 2x raised to the third at the point 1, -1. So they gave me the point, so I'm good there. I need to find my derivative. Now, I hope you notice that I have the product rule. There's an x, and that's being multiplied by a composite function. I'm going to highlight my outside my composite function. There's that parenthesis, and then we have this third right here. So that's the outside. I'm going to underline in blue my inside function. So when I go ahead and take my derivative, so f prime of x is equal to, so we're going to do the product rule. The derivative of the first is 1 times the second, so here's my outside function. Here's my inside function, 1 minus 2x. And I'm going to add that to the first times the derivative of the second. So I'm going to take the derivative of the outside, so we have the power 3, and then we're going to give some space. This is going to decrease to the power 2. And then we're going to insert an inside function, so 1 minus 2x. And then we're going to multiply it by the derivative of the inside, which is going to be -2. At this point, let's just go ahead and plug in 1 in for f, or excuse me, 1 in for x. So f prime of 1 is equal to, so I have 1 times 1 minus, well, 2 times 1 is 2, so 1 minus 2 is -1, so I have -1 to the third plus 1 times 3 times, well, again, 1 times 2 is 2, so 1 minus 2 is -1, so I have -1 squared times -2. Well, that's going to be equal to, this will be -1 plus 3 times 1 is 3 times 1 times -2. That's going to give me -7. So my equation for my tangent line is y plus 1 is equal to -7, x minus 1.